Selamat sejahtera, peace be upon you. Ladies and gentlemen, welcome to Lab Asia 2022 seminar session together with Petroleum Nasional Berhad, Petronas, on rapid assessment of octane number of benzene content in gasoline fuel by Fourier transform near infrared spectrometry coupled with cheometrics. Before we start our session, there are a few rules that we have to adhere. If you have any question, please wait for the Q&A session or do list them down at the Q&A box. If there's any internet disruption during the session, kindly be patient and try to sign in again. In this session, we have Mr. Abdul Rahim bin Othman, Custodian Analytical Technology from Petroleum Nasional Berhad, Petronas. Mr. Abdul Rahim has a working experience in the oil and gas industry for over 30 years. He graduated from the University of Malaya in 1992 with a Bachelor of Science in Chemistry. He has been actively involved in the Malaysia Standard Fuels Specification Committee and Industry Advisory Panel for the University Technology Petronas and University Tun Hussein Own Malaysia. He has a professional membership with Fellowship of the Royal Society of Chemistry UK and Chartered Chemistry Chemist with the Institute of Chemistry Malaysia. Ladies and gentlemen, without further ado, let's welcome him today.
All right, thank you very much, Mr. MC. And Assalamualaikum and very morning to all the audience. So I'm Abdul Rahim from Petronas Nasional Berhad. So today I would like to share with my real case study that I apply on this FTNR spectroscopic and also the chemometrics methodology with the title with rapid assessment of octane number and benzene content in gasoline fuel by Fourier transform near infrared spectrometry coupled with chemometrics. Next slide, please. So this will be the table of contents. I will briefly touch about what is a multivariate all about compared to univariate. So why we need a multivariate, and little bit on the spectroscopy, that the technology that I use for this case study. And the other part is the most important as well, is a chemometrics multivariate methodology. And what will be the benefits and challenges of applying the near infrared for this application. And we go through on the how we developing the methodology of developing the chemometrics modeling, and what are the algorithms that we use for qualitative and quantitative multivariate methodology. And I will share my real case study for gasoline blending, control and optimizations. And at the end of the day, if you have any clarification or Q&A, you can ask me freely. Okay, next please. Okay, our world surrounding us is multivariate. So why we said multivariate? Because, for example, if you want to forecast our weather, there are factors that you need to consider for you to determine whether today is cloudy or today is rainy and so on and so forth. So for example, the factors that we need to take into account, like wind, air pressure, temperature, dew point, and season. So all these factors, we need the sensors to measure. For example, wind, we need the anemometer, air pressure, barometer, and so on and so forth. So by having all the factors and also the sensor, we quantify the value with the proper multivariate mathematics algorithm. So we're able to predict the weather, whether, as I mentioned just now, whether today is cloudy or today is rainy or not. So surrounding us, this is already multivariate. Okay, this is real process in our world. Next, please. Okay, types of multivariate can be consist of sensory data, as I mentioned. We need the sensory data, which will quantify the parameters value, either is concentration or is this a physical properties, so on and so forth. And we need the other part is a spectra and image data. So for example, like when we talk about spectra, we're talking about near infrared and also MRI or NMR. This is all the spectra data that we require. And also chemical data, which is derived from our process data, as all is derived from the reference lab data, which is inclusive. For example, if you are in the lab, so we require, for example, your your cloud point data, your distillation data, vapor pressure data, and so on and so forth. That is required for the multivariate data. Next, please. Okay, so most of the previous things that when we do the process control, we're talking about only univariate. Right? For example, in the cooling water or boiling water, typical parameters that we monitor is the temperature and also pH. If you can see in this data for the temperature, so all the data looks like good. It is there's no outlier, and same goes to the pH. So this is the univariate measurement. So whenever, next slide please, I want to show you what is different when we apply multivariate. When we correlate these two variables, which is temperature and also pH, you can see that there's two outliers. So the multivariate methodology is give you insight or hidden information that is not been shown in the univariate methodology. So that is the beautiful of the multivariate application, which is will not being identified when you apply univariate. Okay, so that's why in the process application, if they use the univariate monitoring, they thought that their system is good, but they still have the failure. So when we apply the multivariate, we can see that at a certain day, there are two outliers for this example when we combine, if we correlate temperature and pH. Okay. Next, please. Okay, little bit some introduction about spectroscopy. I think most of you are familiar when you are in the universities. We're talking about electromagnetic spectrum, which is covers from X-ray, anti-microwave. But for the Fourier transform in infrared, actually the region is called under infrared. As you know that infrared principle is talking about molecular vibrations. So for this particular case study that I did, I only focused on the India infrared region, which is within the 4,000 wave number to the 14,285 wave number. Okay, I only focus on the infrared. Okay. So what are the benefits of challenges using the India infrared spectroscopy technology? So benefits, this is non-destructive, meaning that you won't burn or destroy the samples. You can measure many times, okay? And it's require very minimal sample preparation. And the near infrared also can be integrated with the process. If you start off apply the NR at your lab, you can transfer your model from NR to the online NR for the process control, okay? And it will give you also the chemical and physical information. And as I mentioned, this is non-destructive, okay? So, but there are challenges. However, the challenges can be overcome to ensure that we were able to get accurate and precise prediction. So the challenges like the NR spectra features are broad and undefined, suffers highly from scattering effect. Scattering effect, we can use numbers of algorithm that we can minimize and remove the scattering effect. For example, like multiplicative scatter correction, standard normalized variant. There is a lot of algorithm in the software. And requires multivariate analysis for complete understanding, because we need to have a knowledge about the chemometrics multivariate, how you interpret and evaluate your end results later. Okay. So I would like to touch about, without the chemometrics methodology, the spectroscopy information is not adequate. So we have to combine the spectroscopy with the chemometrics multivariate methodology. So what is chemometrics modeling? Chemometrics modeling, in summary, this is a combine of two disciplines, which is chemistry and also the mathematics and statistics. So chemistry is depend on what technology I use. As my case, I'm using the FNR spectroscopy technology. Maybe some of the cases they are using Raman technology, or they're using NMR technology, okay, to get the spectrum from there. Okay, with the applying the mathematics and statistics, we were able to regress the data that we obtained from the near infrared and also the lab analysis, and we get a predict of either is qualitative or quantitative measurements. Okay, so and what is the multivariate? multivariate is the involves where you need more than one variable for you to do the correlation within the spectra and also the lab analysis. And it will give you one measurement, it will give you more properties. It depends how many models that you develop. For example, you are developing 5 properties, for example. So you will get, within a minute, you will get all the 5 properties results at one time, rather than you have to have 5 different equipment, which is required, consume a longer time for you to complete the analysis. Okay, next, please. Okay, what kind of spectroscopic multivariate application? It can be applied either in the process monitoring and also for the lab quality assurance. So for process monitoring, as I said, it's a very wide broad of application. It's not only oil and gas industry. It can be applied in the pharmaceutical and also for fertilizer and also petrochemical. Of course, there's a lot of application. In my case, I'm from refinery, so I have a lot of application for refinery. Okay, so in the lab, so instead of we are using the conventional method like GCs, physical distillation, vapor pressure analyzer, so on and so forth, we can use the FKNR lab to predict and to do the quality control for daily routine analysis to support the plant requirements. Next, please. Okay, this is my own protocol. So based on my past experience, so I come up with this chemical data analytics protocol. Okay, as a reference for you all. Okay, before you want to embark the carbometrics multivariate methodology for your industry application, you need to define your design of experiment. You need to know what are the sample that you want to measure, what numbers of data you require, what are the parameters you want to develop the model, and what are technology that one you use, whether it's a near infrared, is it Raman, is it NMR. Okay, so when you decide on your design of experiment, and you go the next step, which is descriptive analysis, whereby you will correlate the spectra that you obtain from near infrared or Raman or NMR. So you were able to have the qualitative measurements. Qualitative measurement, it will determine you whether the bunch of the data is it already, there is any cluster or different groups from your data. So it's very powerful. They will give you the insight of the information from the spectra data. Okay. Once you have the descriptive, then you go to the next level, which is for you to do quantitative measurement. Before you're able to predict quantitative of your properties, so you need to develop the model. They call that regression. So you have the spectra, you have the lab data with a proper algorithm, for example, a partially square regression or multiple region regression. So you use that algorithm, so you will develop the model. This model you need to upload into the analyzer for you to predict a new sample. Okay. So once you do the regression, as I mentioned, you will upload the model into your system, then you will be able to predict without doing the lab method anymore. You just measure the NR, so the NR analyzer will predict the quality. It can go 8 or 10, it depends how many properties that you model. Okay, the last or not least, once you successful implemented at the lab scale, so you were able to transfer your application into the real time for process control and optimization. So this is a summary of the chemical data analytics protocol. Okay. So as I mentioned, if you want to do the qualitative measurement, one of the method that we use and that I use for this one is a principal component analysis. So what the things that PCA done actually is to do the exploratory data analysis. They will extract information from your near infrared spectra. And before that, you need to remove the noise. Noise is something like, I mentioned just now, that scattering. Scattering is because the presence of the particle solids or maybe other particle that we need to remove for you to get a better spectra. So there is an algorithm, as I mentioned, MSC, SNMB. So this will give you some insight. It's not give you quantified parameter, but it gives you some insight whether there is a significant variation of the process or there is any clusters or grids within the data that you obtain from your near infrared. Yes, please. Okay. For you to use chemometric for quantitative, as I mentioned just now, you need to develop the model. Okay, so X is the spectral variable, plus Y is the lab results from the conventional method. For example, your distillation, your pour point, your clock point, your CTN index, which is derived from your lab conventional method, with the combination of both with the proper algorithm, which is partially square. So you will develop the model. So once you develop the model, you will upload into the analyzers. Then you just run the spectra without doing the lab method. You will get the prediction of each property that you already developed the model. Okay, so this is two stages. Stage one is calibration. Stage two, we complete, you upload, and you were able to predict the new sample with the properties at one time. Okay, so partially square actually is the multiple linear regression. Okay, this is already embedded in the software. Okay, all right, next please. Okay, in summary, as I mentioned just now, so multivariate analysis and spectral data consists of one is qualitative measurement, and the other one is quantitative measurement. Okay, you can see the upper one is the quantitative measurement, where I said you need a spectra and you need the lab reference data, and you develop the model, and you can regress and get your model and upload into the system that you will predict the properties. And for the qualitative, we are using PCA. So in the case, you see, we get all the NR spectra. The spectra were able, the PCA were able to provide you the insight, whereby we have a 4 clusters here. You can see that the red one, we have both gasoline, and this gasoline also, we can have the insight or the information saying that this gasoline is 2 cluster. Why is 2 cluster? Because it's 2 grades. One is 92 grades, and the other one is 95 grade. And the other one is the diesel and kero. Although in the information looks like same, when we apply the algorithm, the multivariate algorithm, we were able to obtain the insight, the information from this methodology. So it's very powerful. So in your case, if you have other industry applications, you have different grade. By having this PCA model, qualitative, you were able to determine whether your grade is a grade A or grade B or grade C. Okay. So in summary, regression model for future prediction will replace expensive and destructive testing that you normally we have in the conventional lab. And it's a very rapid analysis. As I say, it's less than 1 minute, okay? And reveal the true structure of the data, okay? And it will increase the lab efficiency and productivity. And the other part, for the long run, you will reduce the capex and opex as well, okay? Next, please. Okay, I would like to share my real application, which is really successful, that I apply this FTNR chemometrics multivariate in our gasoline blending control and optimization. This is my real case study. Okay, when we talk about gasoline in blending, there are a few things that you need to have certain knowledge. Okay, you need to already know that when we talk about gasoline blending. One is when we do the gasoline blending, this is required multiple constraint properties for control optimization. So it's like when you're baking the cake. So you need a numbers of recipe. Okay. So same goes to the gasoline. Okay. It depends on the refinery, how many blending components that they use and what are the ratio that they use. But ultimately, they want to get the gasoline grade, whether grade 95 front or 92 or 97, it depends on the refinery. So, but what I'm trying to say is really required a multiple constraint property to control. Okay. And the other one is blending is a long duration. Typically, it will take about 10 to 12 hours. It depends on the production. Some of the refinery, it can go up to maybe 16 hours. It depends on the volume of the production. And the recent requirement is now is to meeting the Euro 5 gasoline specification. But at the moment, Malaysia is still Euro 4. But I think in another 3 or 5 years, we are going towards the Euro 5 gasoline. It's a very stringent. That is really required a very accurate and precise online control and optimization of the gasoline. Okay, next, please. Okay, in industry, before we embark this technology and methodology, we have the pain points in terms of gasoline blending. For example, the first pain point is a high productivity giveaway. So what we mean by high productivity giveaway? For example, I'm talking about the Octane number. So if the octane number spec, for example, is 95 minimum, but if you giving 95.3, actually it is the loss to opportunity to the refinery, because 0.1 octane number is equivalent to $1 per barrel. Okay, so imagine if you give away 0.3 octane number, which is that $3 per barrel. So for refinery, typical production of gasoline is about 45 to 50,000 barrel per day. So it's a lot of money in 1 year. It's $1 million we lost if this is high quality away. And even this is previously the frequency of reblend is very high. It's about 20 to 30%. We need to reblend. Either we reblend because of the giveaway, high giveaway, and also because of the spec. It's not meeting the spec. So this is a commissioning method before we use our FKR technology. And because of the high frequency reblend, you need to do the correction, and then you need to pay high demurrage costs and inventory holding costs. The ship is already waiting at the port, so we can't deliver the product because we need to reblend. So this is also incurred a very high cost to us. Okay, and COQ issued by a lab required about 12 hours. This is very long, 12 hours. So by having this technology to be deployed for the gasoline blending, so what we see that we're able to reduce product giveaway is a lot, and reduce reblend certificate from our record, we have 0 reblend. It's very significant success story that we have, and from there we able to minimize the demurrage cost. And we have the online certification, which is less than 1 hour. Okay, next, please. So in QC lab, what are the pain points? So of course, when you use the commissioner, for gasoline, there are about maybe more than 10 properties and required 10 analysis different equipment. So it's a time consuming and it's so sophisticated, which is required highly competent people to operate, and it's expensive analysis costs and high OPEX to maintain all the equipments. Even the HSC risk, which is you were exposed to the chemical, and as I mentioned, it's required high skill technician or chemist to operate the equipment. So by having the multivariate, so we able to accelerate the analysis, rapid and simple measurement per minutes, and very low analysis costs, low OPEX, okay, very minimum chemical exposure. Even we only exposed to the hydrocarbon, it's a very minimum, which is less than 1 ml, okay, and easy to operate. All right. Okay. For my my case study, I just want to share about octane number, and also the other one is the benzene content. Okay, this is the current method, conventional method, which is STM 2699, where we determine the research octane number. Either your gasoline is 95 grade or 92 or 98. So this is a very expensive CFR engine. It's $1 million. Even the maintenance cost is very high and required high skill, competent technician or chemist to operate. And it's required 1.5 to 2 hours to complete the test. And the method reproducibility is 0.7. Okay. Next, please. And the other properties that I would like to share is the benzene content, which is by gas chromatography. Is a multi-dimensional column, which call that informalizers, and we report in either in the hydrocarbon group, and specifically for this one we report as a benzene content volume %, and it require 45 minutes to 1 hour, and again is require highly competent staff to operate. Next, please. Okay, so this is what the outcome that I'm obtained from the principal component analysis. You can see that looks like there is 2 clusters for gasoline. So you can see the upper one is around 96 and 97. The other one is 94 for 95. So without doing the analysis by applying the principal component analysis, you will able to do the qualitative measurement, and you will able to identify whether there is more than one groups, or there is any grades that we can obtain from this information. Okay, next, please. Okay, for quantitative measurement, as I mentioned just now, you need to develop the model, right? So before you really deploy your model, you have to evaluate your model, whether your model is acceptable or not, because this is very important. You not just develop a model, then you update model, then you deploy for the process control or for any other purpose. It's not right. So you need to develop the model and evaluate it. So my methodology, this is my methodology. Okay, most of the I think the vendor, they are using very less stringent acceptance criteria. They're just looking on the standard error prediction of an R should be less than method reproducibility. So in my case, because I'm looking on the product, so I put a very stringent performance evaluation criteria, whereby I'm looking on the RMSCP, I'm looking on the F test, T test, and also the robustness of the model. Okay, next please. Okay, this is my real data for Octane number. If you can see that the standard error prediction is SCP of this model is 0.5, whereby the method, our method is 0.9, because my model is covered until up to 103 Octane number. Okay, not to 97 or 95. I have a wide range of the Octane number data. So it's very good. It's about, I think, almost half from the method reproducibility. Okay, then even you can see that the R square is about 87%. Okay, so multivariate, again, I want to emphasize regression coefficient is not really the mandatory say that mandatory acceptance criteria, because multivariate, you sometimes you don't get 99.99 like univariate. Okay, if you have 99.9, this is something like too good to be true. Okay, because this is multivariate. So most important when you evaluate your model, you want to see the standard error prediction and also the root mean square error standard error prediction, SCP, and also RMSCP, and you compare with your method reproducibility. Okay, next please. And okay, once you do the calculation, so I have another set of data which is 264, a new data. I predict the new data, and this is the performance of my validation set. You can see the SCP is 0.4, RMSCP is 0.46. So again, our method is 0. Again, half from the lab reference method reproducibility. It's very good, very, very good. Next, please. And same goes to benzene. This is my calibration data. So SCP is 0.1, our method is 0.99, but what I obtained for this calibration model performance, I got SCP standard error prediction 0.12, RMSCP also is about same 0.12. So, and even R square is 98%. Okay, next please. And this is my validation data, which is not in the calibration. It's the new data, which is 204 data, new data. So again, the SCP, RMSCP is meeting the R method reproducibility. Also very good. So with this criteria, so I say that my model is meeting the criteria and is now ready for real application. So this protocol is very important. Okay, right, next please. Next please. Okay, this is overall performance. So even you can see robustness for Octane number is 20 and benzene robustness for 42. Robustness really depends on the wide range of your sample. Okay, if your range, your sample range is too narrow, so it's not really robust. So it's good for you to have a very robust model which covers from the low range and until the higher range. Okay, for you to get a high robustness. So typically, some of the teachers saying that your robustness should be more than 10. Okay, so for us, this is double. Even benzene is 42. Okay, next please. Okay, this is a real verification that we obtained for the gasoline product blending optimization. You can see at the left side on the before we implement the FTNR. So the giveaway of run is about 0.2. So if we apply the FTNR online for the product blending optimization, you can see that our giveaway is 0.03, or the number is below than 0.1. So it's a lot of money. We save a lot of millions of dollars per year. And our estimation production gasoline is about 40K to 45,000 barrels per day. And as I mentioned, 0.1 Octane number giveaway is equivalent to $1 per barrel. Okay, this is very excellent achievement that we obtain when we apply this technology. Okay, next please. Okay, we still continue our performance. So up to 2020, we still able to minimize, maintain our giveaway below than 0.1. Okay, number. Next, please. Okay, of course, when you apply the near infrared technology and also chemometrics multivariate, so there are challenges in future. For example, the variation of crudes and blending components in future. For example, like our model currently, we don't have ethanol, for example, or we don't have any biofuel component in our tool. So if there is a requirement, then you need to update the model, because the current model space is not covered for example, ethanol component or ETB component or any biofuel component. So you need to embed the new component into your calibration model space. Okay. The other one is stringent fuel specification required high accuracy and precise measurement. For this one, although it's a challenges, but the prerequisite before you deploy the multivariate methodology, you need to make sure that your reference method performance is tip-top, meaning that your method, reference method, conventional method, precision, it should be better than method reversibility, because the model, the input is coming from the lab reference method. If the input is bad, then the output is bad. So number two is certainly depends on the lab reference method performance. Okay. The other one is the acceptance from customers and regulatory on the new alternative method, which is using the multivariate. But actually, there is a international accepted method, STM. There's a lot of method, STM E1655, STM 6122, and the others method. Actually, already mentioned about the near infrared multivariate methodology. So I didn't see any constraint for you to convince your customer or regulatory using this methodology, because now we are going towards the data analytics. So should not be a problem. We are aligned with the IR 4.0. Okay. And the other last on the list is the sustainability of deployment. Okay. So you need to have, once you deploy the multivariate methodology or technology, so you need to have a proper QA/QC for you to monitor and to sustain the NR deployment. And also in terms of resources, the talent, chemometrician, we need to maintain the competencies. So I think that's all from my side. If you have any clarification or you need to have discussion, I'm willing to share and to answer your questions. Thank you very much.
Thank you, Mr. Abdul Rahim, for this remarkable and great presentation. Now we have come to the Q&A session, and I know the audience listening could not wait for our speaker to answer the question. Once again, we would like to remind fellow attendees that are currently live watching, if you have any question, please list them down at the Q&A box, and we will do our very best to answer all the questions that you guys have put it in. So for a start, Mr. Abdul Rahim, we would like to ask which overtone region you use for the calibration modeling?
Okay, that is very technical questions, so I try to answer. Okay, when we talk about near infrared overtone region for near infrared, I'm not talking about medial region or far region. So as I mentioned, near infrared region is covers from 4,000 wave number until 14,000 wave number. Okay, it's up to the technology provider of the FNR. If you are using the different set path length, for example, in my case, I'm using the 0.5 mm set path length at the 25 degrees C temperature. Okay, so for my for this setup, okay, configuration, I'm using the combination overtone. Okay, so but certain technology provider, they are using 2 mm set path length. Okay, then for the 2.0 mm set path length, so the best overtone is the first overtone. Okay, so it certainly depends on the technology provider that you engage. Okay, that's my answer.
I see. So then how do you ensure that like the test results like predicted is technically valid then?
Okay, that's another tough question. I believe For you to convince your stakeholders or your customer, you have to make sure that your NR prediction quality is equivalent to your lab method, right? So that's a very detailed explanation. Actually, people need to attend my class for me to explain detail. But anyway, I tried my best to answer. So when you develop the calibration model space, there's a requirement of you to configure your if the term is a discrimination limit, your model space, you need to configure your discrimination limit in terms of range, in terms of your scores, in terms of your residual. So it's very technical words. Okay, so if mathematician they know what is these terms. So we put the discrimination limit, the minimum and maximum. So whenever you predict, if the model is within the model space, the new sample. So if not all higher, that is a trigger that your result is technically valid. Okay, that's one way. The other way that you need to have a proper QA/QC protocol in your system, whereby every 2 months, every 2 weeks, you need to monitor your model performance. Your model performance monitoring also important. Okay, so that's I can answer in summary.
I see. Okay. So, ladies and gentlemen, once again, we would like to remind fellow attendees that are currently watching that if you have any question, please list them down in the Q&A box and we will do our very best to answer all. It would be great that if we have an interaction session. So, Mr. Abdul
Yeah.
So what is like the cell measurement temperature that you use mostly on during your experiment?
Okay. The cell measure temperature is depend on the characteristic of the sample. Okay. So for example, like gasoline application that I shared today, I'm using the 25 degrees C because the gasoline actually is not solidified at room temperature, and we require 25 because to ensure that there's no light hydrocarbon will vaporize that will affect you in terms of accuracy. But for example, that if you have a sample that's solidified at room temperature, so and the pour point, for example, is like 30, for example, so you need to have about 25 degrees above your pour point for your cell temperature. Okay, so it depends on the nature of your samples. For the hydrocarbon application, I'm talking about hydrocarbon application. But for the solid application, fertilizer application, normally there's no required for the temperature measurement. They just measure at the ambient temperature.
I see. I'm connecting from the platform and the platform has yet sent us any question, Encik Abdul Rahim. So I believe that if there's any question that you would like to ask Mr. Abdul Rahim again, please, we will give you, please send your inquiries to us and we will connect you directly to him. And most importantly, I believe that Encik Rahim have already explained a very detailed presentation today. So I think that's why most of the audience also have no questions so far. So Mr. Rahim, do you have, before we end our Q&A session for today, do you have anything that you would like to add, or maybe like you would like to share with us what are like the vision or the goal for the next future for Petronas under your care?
Correct. So specifically for this technology and the chemometrics methodology, actually is a part of the strategic initiative. So personally, I myself as the head for Petronas analytical technology across Petronas downstream upstream, I'm deploying this technology across Petronas application, either in the refinery, either it's a petrochemical or fertilizers. Okay, because this technology and methodology, the data analytics is aligned with the current IR 4.0, right? And then for the analytical chemist group, for the industry, I really urge that you have to be sensitive also whatever there's a national agenda in terms of strategy agenda with regards to the data analytics, whether it's a predictive analytics or advanced predictive analytics. There's a lot of algorithm that we apply for process control and also quality control, like artificial intelligence, artificial neural networks. It's a lot of things. So this is a part of how the analytical chemists can contribute towards that initiative technology agenda. For Petronas, this FTNR chemometrics is one of our one of our specialized engineering solution. We providing the consultancy and services. So if any industries out there or any audience, if you want to have the consultancy from Petronas, so we have a pool of competent people that can help you. Okay, we have a very good numbers of projects that we already successfully deployed across Petronas. Okay, that's all from me.
All
MC.
right. Thank you so much, Mr. Rahim. We are truly honored to have you with us today, this morning. So, ladies and gentlemen, that are still watching, if you would like to get in touch with Mr. Abdul Rahim, do send your inquiries and we will connect you directly to him. So, before we end the session today, we would like to say thank you for joining the session. If you have not visited our virtual exhibition hall, we would like you to spend your valuable time to explore our virtual platform and start networking with all the industry key players that are currently participating. Also, don't forget to follow us on all our social media platforms for more updates. Once again, we would like to say, if you would like to get in touch with Mr. Abdul Rahim, do send your inquiries and we will connect you directly to him. Once again, thank you for joining and have a great day ahead.
Thank you. Bye.